Imagine an AI that doesn't just answer your questions, but can actually build other AI models completely from scratch. An AI that can just waltz into a data science competition against human experts and actually win. And no, it sounds like something straight out of science fiction, but a brand new approach is making this a reality. And honestly, it could totally change how we build intelligent systems. So let's dive in and see how this thing actually works. Okay, so here's our game plan. First, we're going to talk about the big problem. Why the first AI coders were so, well, clumsy. Then we'll meet the new, smarter agent that's designed to fix all that. We'll take a peek under the hood to see how it thinks. Then we'll really put it to the test in a high-stakes showdown. And finally, we'll ask the big question. What does this mean for the future of automation? All right, let's get into it. Section 1, the clumsy AI coder. Look, building a top-tier machine learning model is a ton of work, right? It's super labor-intensive, even for the best human experts. So naturally, the first idea was to get an AI to do it. And those first attempts, they were promising, but they had some really serious flaws. And here's the core issue. These early agents are basically stuck in the past. They can only use the knowledge they were originally trained on, which might be years old. It's kind of like asking a mechanic who only knows about 2015 cars to fix a brand new 2025 EV. I mean, they know the basics, but they're missing all the latest, most important techniques. And when they run into a problem, their strategy is, well, it's not exactly subtle. This is where you really see the difference. A human expert is like a surgeon. They'll run diagnostics, they'll find the one thing that's causing the problem, and they'll make a really precise, targeted fix. The older AI agent, it's more like a demolition crew. It sees a single cracked window and decides the only solution is to tear down the entire building and start from scratch. It just tries to modify the whole code at once, which is, you guessed it, just incredibly inefficient. So, if that's the problem, what's the fix? Well, that brings us right to Section 2, a smarter kind of agent. To solve this mess, researchers came up with a totally new approach, one that thinks less like a sledgehammer and more like a seasoned pro. It's called MLE-STAR. And the name itself tells you pretty much everything you need to know. MLE-STAR stands for Machine Learning Engineering Agent via Search and Targeted Refinement. See the star in there? It's designed to attack the two biggest problems we just talked about, that old, outdated knowledge and the clumsy, brute force fixes. And it all comes down to two superpowers working together. First up, web search. Before it even thinks about writing a line of code, it hits the internet to find the best, most modern ways to solve the problem. No more dusty, old tools. Second, and this is the cool part, is targeted refinement. Instead of demolition, it acts like that surgeon. It runs these scientific tests to find the single, most critical block of code, and then it pours all of its energy into making just that one little piece better. This brings us to Section 3, how MLE-STAR thinks, because this methodical, step-by-step approach is what makes it so incredibly powerful. So let's walk through how it actually tackles a problem from start to finish. This whole process is built around this brilliant feedback loop. It kicks off with a search, finding the best stuff online. Then it initializes a first draft of the code. But this is where the real magic happens. It targets the single most important chunk of code, refines just that one part until it can't make it any better, and then it repeats the whole process, moving on to the next most important block. It's just this relentless, super focused cycle of improvement. But wait, it gets even smarter. The system has these built-in safety checkers specifically designed to catch the kinds of subtle but totally critical mistakes that large language models make all the time. And one of the biggest, most dangerous errors in all of data science is something called data leakage. Let me show you exactly what this mistake looks like in the code. See here? The AI has combined the training data and the test data before it starts doing its calculations. This is a huge, huge no-no. It's basically like letting a student peek at the exam answers while they're still studying. The model gets information that it never should have seen, and you end up with a score that looks amazing but is totally fake. MLE's safety checker catches this immediately and rewrites the code the right way. First, it processes only the training data to figure out all the stats it needs. Then, it applies those exact same stats to the separate test data. This completely prevents any data leakage and makes sure the final result is 100% legit.
Okay, so this all sounds incredibly smart, incredibly sophisticated in theory. But now let's get to the fun part. Section 4, putting it to the test. How does MLE-STAR actually hold up when it goes head-to-head with other agents in the super competitive world of Kaggle data science competitions?
This is the moment of truth, right? Does this smart surgical approach of searching and refining actually give it a real advantage when it counts? The answer is a huge, resounding yes. I mean, just look at these results. On a benchmark of real Kaggle competitions, the best competing agent, called AID, wins a medal about 26% of the time, which, hey, that's not bad at all. But MLE-STAR, it wins a medal in almost 64% of the competitions. That isn't just a little better. We're talking about a completely different league here. Just let that sink in for a second. Nearly 2/3 of the time it competes, this AI produces work that is good enough to land on the podium, often against thousands of human experts. This isn't just some slightly better algorithm. It's a fundamental shift in what we thought automation could even do. And this table here, this is what I find really fascinating. It shows that it's not just about raw power, it's about having a better strategy. Look, even when MLE-STAR uses the exact same underlying model as its competitor, its smarter approach wins way more often. But then, when you give that brilliant strategy a more powerful brain to work with, like Gemini 2.5 Pro, the results are just staggering. It's winning gold medals over 1/3 of the time. So all of this leads us to our final section, the future of automation. Because yeah, these results are impressive in a competition, for sure. But the real implications here go way beyond just winning medals on Kaggle. So what does this all mean for the future of AI? Well, it really boils down to 3 huge things. First, AI development is about to become way more accessible. Companies that don't have these giant teams of data scientists can now create really powerful custom models. Second, it's so much more efficient. It automates all the tedious, repetitive work, which frees up human experts to solve bigger, more creative problems. And maybe the most important part, it's continuously improving. Because it learns from the web, the second a new, better model is published anywhere on Earth, MLE-STAR can start using it. It literally gets smarter all by itself. And this really forces us to ask a much bigger question. We used to think about automation as being for repetitive, manual jobs, but now we are watching AI master a field that requires deep knowledge, a ton of creativity, and really complex problem solving. So if AI can master data science, you really have to wonder, what field of human expertise is next?